Everyone, myself bablu Sahu. My seminar topic is MOS diode. Today I will discussing to MOS diode introduction. MOS diode is the full name of metal oxide semiconductor. MOS diode is most useful in semiconductor structure. A basic MOS consisting of three layers. The top layer is metal, conductive metal electrode. The middle layer is insulator of glass or silicon oxide. Bottom layer is another conductive electrode made out of crystal silicon. This layer is a semiconductor whose conductivity change either in doping and temperature. And cross section of MOS diode. D is thickness of the oxide and V is applied voltage on the metal field. If V greater than 0, metal plate is positively based with respect to the ohmic contact, and V less than 0, metal plate is negatively based with respect to ohmic contact. Radial MOS. In this section of radial MOS, metal oxide semiconductor gate and bulk body terminal. The conditions are began to take or first that the work function of metal and the semiconductor between psi phi m is equal to q phi m is equal to q phi s. And second condition, the oxide no charge exit in the diode. And third condition is oxide has infinite resistive. And fourth, no surface states at the silicon dioxide silicon interface. This oxide find the resistive. They not current the flow through the oxide applied voltage in this section of radial MOS. And energy band level. This section of energy band level and metal oxide semiconductor. Metal, the vacuum energy level is E0 and different E0 to EF and volume Q phi m. And oxide we have E0 with and EC defined to respect to E0 with volume Q chi. And semiconductor EF constant and potential energy. And that the work function of metal and the semiconductor between Q phi ms is equal to Q phi m minus Q phi s is equal to Q phi m minus Q phi m minus Q chi plus E2 by 2 plus Q sin B. when ideal. In this section, energy band level. When ideal, most diode is based with positive or negative voltage. Those cases might exist at the semiconductor surface. A. Accumulation. B. Deflection. C. Inversion. And A. Accumulation. Accumulation. B. Less than zero excess positive carrier will be inducted at the silicon dioxide silicon interface and bond near the semiconductor surface are bent upward. P is equal to NIE power e the power EI minus EF upon KT. And charge distribution QS QS is equal to 1 QML. QS plus charge per unit area in the semiconductor. Here deflation. V greater than zero bands near the semiconductor surface are bent down off and the major carrier holes are depleted. Charge disturbance QNAW space charge per unit area, W width of depletion region. Inversion. Here and inversion. Larger plus V positive voltage is applied. EI cross over the Fermi level. Electrons is greater than holes. Weak and strong inversion electron concentration in interface equal to the substable doping level. After this point, additional E in N type inversion layer QS is equal to QN plus QSC is equal to QN minus QNA WM. The surface depletion region. We can energy band diagram at the surface of a p-type semiconductor. We can q phi to replace E and get this equation. Np is equal to Nie the power q psi minus psi b divided by kt. Pp is equal to Nie the power q psi phi minus psi divided by kt at the surface. At the surface, Ns is equal to Nie the power q psi s minus psi b divided by kt. Ps is equal to Nie the power q psi b minus psi s divided by kt divided by kt. फिर psi s less than 0 accumulation of holes bend upward, and psi s is equal to psi 0 flat band conditions, and psi b greater or psi s greater or 0 depletion of holes bent down upward, and psi s is equal to psi b intrinsic concentration, and psi s greater than psi b inversion bend downward by using the one-dimensional Poisson equation. Del square psi upon del x square is equal to minus ps x upon epsilon s. Px is the charge density per unit volume at position x, and epsilon is the dielectric permittivity. When the semiconductor is depleted to a width of w, and the charge within the semiconductor is given by ps is equal to minus qna. Integration of Poisson equation, we get the electrostatic potential distribution as function of distance x in the surface depletion region. Psi is equal to psi s 1 minus x upon w का होल स्क्वायर. Psi s is equal to qna w square to epsilon s. When strong inversion ns is equal to na from na, फिर रह गए ns is equal to nie q phi s minus phi b divided by kt, and na is equal to होता है nie q sin b divided by kt. From psi s is equal to qna w square upon 2 epsilon s, we can get the maximum width of the surface of depletion region is wm is equal to 2 epsilon s psi s inversion upon qna. Wm is equal to under root 2 epsilon s psi s inversion upon qna is equal to हो जाएगा 2 epsilon s 2 psi b upon Q and W m is equal to 2 under root epsilon s kt log in Na upon Ni upon Q square Na. This